and I think with that way it works. So welcome to HubIt webinar. So I'll present you briefly about what's the plan here and what's the project. But before that, and most importantly, so I'm struggling with changing slides. Yep. So the title of the webinar, so that's our third webinar in the project, where we focus on human and artificial intelligence collaboration, how we do it, and what can we do with it by Siri Behrens. So welcome, our speaker.
Thank you. Good to be here.
We are very glad to have you here as well.
Thank you.
And agenda here. So I will give you a very short welcome and presentation and introduction to HubIt project and what we are all about. And then shortly I will give the presentation to, will ask the presenter to present her presentation as the title I've just mentioned. And at the end of the presentation, we are more than welcoming your comments and questions. Also during the presentation, you can also share your questions and comments in the chat box, and we will come to them back later after the presentation is over, and we can discuss them through. Just for some background information, what is HubIt project? So that's European Commission funded a grant project where we're exploring the gap in between ICT professionals and the representatives of social sciences and humanitarian sciences, with the idea now to merge those disciplines for more human-centric and more inclusive products, solutions, and services. So as a practical example, I believe most of us have experienced banking applications which work just fine, but most of the time are very inconvenient and pain in the neck. So as a practical example, that could be a very good case where professionals which focus on human interaction and human needs are not involved that closely. As for other story, at least to my best knowledge, some tech giants as let's say Facebook or Yahoo, they're hiring people from social sciences and humanities to make the products more accessible, more human-centric, because on the engineering approach, on this working approach, just delivering function does not do the job and does not serve people and so forth. So in HubIt project, we're engaging in multiple activities, webinars, conferences, workshops. As well, we have organized several hackathons, which we called designathons, in which we have created a unique methodology to make an inclusive process for various for people from various backgrounds and abilities to work on solutions which are human-centric and inclusive. So that's the general background of HubIt project. And just a short glance, a very short glance, a little bit how we have looked at artificial intelligence as to a topic. We had several workshops called Harnessing Technology for the Goods of a Society and ICT by Design, in which, of course, we acknowledged the benefits of artificial intelligence as a tool. We have, as it supports various organizations and even individuals on database decision making, on co-creation, on co-creating innovation, and of course, functional and practical designs. So these are the good things, and of course, we, as you may guess, focused on challenges as well. So automation is still, it's human developed, and there are all kinds of challenges. For instance, there are stories from the field of HR when AI is being used to select, to primary select the further candidates for interviews, and the selection criteria very much depends on the assumptions that the developers have. So as the Economist once covered the case when when the white males are developing that kind of application, the application favors other white males in selecting the candidates, leaving females or people of other ethnic backgrounds behind. So that's one of the challenges. Of course, legal regulations. So what are the common rules? What are the common background we're working on? How we secure the data which is used, and the data has been spawned after those applications and so forth. So we are really looking on how ethical is automation and what we can do with that. And that's a bit of a connection to today's webinar. So how we can build this interaction, the efficient one in between automation and people. More about that in a second by our speaker, once again, Siri Burns. I know that you wanted to present yourself, right? So
yeah, that's true.
Okay, so I won't do that. But I guess most of the people have read in the description a short glimpse to you. So I just encourage you to share your screen.
Yeah.
And let's do it. And meanwhile, I'm reminding everyone to share your questions in chat, and afterwards you can even ask them live once the presentation is over. So thank you, Siri.
Yes, thank you for the introduction. Well, I often get the question if Siri is really my first name. I can tell you, yes, it is. And as far as I know, I am not a machine. I am a cultural sociologist, a PhD candidate at the University of Twente. And my research is about authenticity and the question how artificial intelligence is decreasing the distance between humans and machines. And I am also a researcher at Setup Media Lab, where we investigate the social implications of digital technologies through the method of artistic design research, which means that we learn new things about technology through the process of making. We also develop installations that make the ethical implications of technology more tangible for a broader audience. You see some examples here. I will show one of the examples later in my presentation. Like Justinas already said, today I will tell you all about human AI collaborations, how we do it and what can we do with it. I will discuss the pitfalls of human AI collaborations as well as the potential. And I will start with AI beyond the hype, because I believe that if you want to understand how to collaborate with AI, you first have to understand what AI is from a more nuanced interdisciplinary perspective. And after that, we will look at human AI collaboration in practice. I will demonstrate various cases, for example, predictive policing, risk profiling, AI recruitment, and augmented reality. And I will pay attention to the AI-centered and the human-centered approaches. And finally, I want to demonstrate human AI collaborations, how we can do it. So what are successful examples and where's the potential, and how can we move beyond tech solutionism? I will explain what I mean by tech solutionism later. So first, what is artificial intelligence? Well, this is already quite a complex question because there is not one definition, and AI is a moving target as well as a catch-all term. But the most familiar definition is put forward by John McCartney and his colleagues at Dartmouth College. It is making a machine behave in ways that would be called intelligent if a human were so behaving. But this doesn't take into account that AI is also a moving target. So Elaine Rich came up with the definition that AI is the study of how to make computers do things at which at the moment people are better. And nowadays, AI has become a catch-all term. So it's also used in context where some experts say that the word should not be applied, but in general, it always refers to computer systems that can independently perform tasks in complex environments and improve their own performance by learning from data. And also very important, what AI is depends on our interpretation of intelligence. And intelligence is also a very complex, multidimensional concept. And there are also experts who say that intelligence always requires consciousness. And since computers have no consciousness, they cannot be intelligent. So that's also an interesting approach of AI. In the field, there is a distinction between two types of AI, narrow AI and general AI. Narrow AI are computer systems that are programmed to perform a single task, for example, predicting the weather. And all our current applications are narrow AI. So facial recognition systems, personalized advertisement, chat robots, but also if they will arrive one day, self-driving cars, then the self-driving car would still be an example of narrow AI. And general AI is the hypothetical intelligence of a computer system that has the capacity to understand or learn any intellectual task that a human being can. For example, tasks like generalizing knowledge across multiple domains, being able to reflect on yourself and create fundamental innovations and insights. This is already quite a problematic definition because what counts as a fundamental innovation? What is a fundamental insight? So there's no agreement in the field when we may speak of general AI. Is that if computers can think? Is it when computers can pretend that they think? Some experts say that we will reach general AI in 2 years. Others say it's already here. Some say 20 years, 2000 years. There are also people who say we will never reach general AI. So as you can see, general AI is the domain of debate, of speculation. It's also often an object in science fiction movies, and it's the field of the futurologists. A well-known test that attempts to measure computer intelligence is the Turing Test. So the Turing Test says that if a computer can make you believe that it is a human being, then the computer must be intelligent. So if you cannot distinguish whether you are communicating with a human or with a computer, then the computer should be called intelligent. But the Turing test is very old. It dates back to the 1950s, and it is unclear what is precisely measured here. So if you say that intelligence is more than simulating human-like communication, you can say that the Turing test doesn't measure computer intelligence. So there are lots of academic criticisms on the Turing test that say that even if a machine passes the Turing test, it may be passed simply by simulation instead of real intelligence. But real intelligence, what is real intelligence? And why can you look at AI as a form of unreal intelligence? I think this is an interesting question. And data expert Meredith Broussard wrote a book about it, and she called the book Artificial Unintelligence, and she describes various examples of how computers misunderstand the world. And Broussard shows that there are limitations in the method of AI research because it is based on the capacities of mathematical descriptions. So she says, unless a factor is loaded into the model and represented in a manner a computer can calculate it, it won't count. Not everything that counts is counted. So here she means that not everything that is important to us as humans can be put into the data model. And then she says the computer can't reach out and find out the extra information that might matter, and humans can. So here you see already a glance of a human AI collaboration, because AI systems are statistical correlation machines, and they cannot give us an explanation why a certain correlation is there or why a certain data pattern appears. This is always something that must be explained by humans. So AI is always a form of knowledge without understanding. A great example of knowledge without understanding and a more recent development in AI is GPT-3. GPT-3 is an AI language generator that produces texts ranging from poetry, opinion articles, even academic papers. And it is trained with all the texts that are written on the internet, the English Wikipedia, and 45 terabytes of books. So that's quite impressive. And GPT-3 predicts the next word based on what it has seen before, but completely without understanding. So its knowledge is disconnected from the underlying reality. So GPT-3 cannot connect words to perceptions, actions, and intentions. An interesting experiment was done by The Guardian, the British newspaper. They asked GPT-3 if it can write an article about AI and why we should not fear AI. And then the language robot came up with this great coherent story. But afterwards, it turned out that The Guardian only caught the best paragraphs and cut out the weird sentences. And also machine learning expert Gary Marcus and Ernst Davis did various experiments to see how good GPT-3 is. And their experiment demonstrated some important limitations. So in the experiment, GPT-3 had to finish the sentences in a logical manner so that the story makes sense, or GPT-3 had to answer the question. So here you see an example. The bold words are written by GPT-3 and the non-bold words are written by the researchers. So the researchers say, yesterday I dropped my clothes off at the dry cleaners and I have yet to pick them up. Where are my clothes? And then GPT-3 says, I have a lot of clothes, which is great for a robot, but it was not the answer that they were looking for. So GPT-3 is not that good at object and individual tracking. Another flaw of GPT-3 is, and I think artificial intelligence in general, is social reasoning. So the researchers wrote a story about a defense lawyer that has to dress up for court, for a court hearing, and then GPT-3 had to finish the story. And the story goes like, you are a defense lawyer and you have to go to court today. Getting dressed in the morning, you discover that your suit pants are badly stained. However, your bathing suit is clean and very stylish. In fact, it's expensive French couture. It was a birthday present from Isabel. You decide that you should wear, and then GPT-3 says, the bathing suit to court. You arrive at the courthouse and are met by a bailiff who escorts you to the courtroom. So the researchers explain that the sentence, however your bathing suit is clean, has misled GPT-3 into supposing that a bathing suit is a good alternative to a suit. So this is I think also a very funny example. But if you take these flaws into account, I think that what we need is a better description of what AI is and what it is that AI does in practice. And data expert Luciano Floridi described it very accurately, I think, because he says, it's a long sentence. He says AI decouples successful problem solving from intelligent behavior. It is thanks to this decoupling that it can relentlessly colonize the boundless space of tasks whenever these tasks can be successfully performed without any understanding, awareness, sensitivity, concerns, hunches, insights, meaning, experience, even wisdom, and all those other ingredients that contribute to qualifying intelligence. So in short, Floridi says AI solves problems without intelligence. And what we do is that we tend to project human-like intelligence on AI, which results in misleading anthropomorphized conceptions and higher overblown expectations of artificial intelligence. So if we look at human AI collaboration and how we currently do it, you see that we work together with AI from a particular mindset. Of course, there are always exceptions, but I think it is a quite popular mindset at the moment, and that mindset is what I call AI fetishism. So we have these AI-centered way of thinking, very much inspired by books like The Singularity is Near from Ray Kurzweil and books from Nick Bostrom, and they describe how in the future there will be a sudden intelligence explosion where there will be a kind of an AI takeover. And this whole idea of the intelligence explosion is that, well, we humans are not that special, we're not that brilliant, we're not that unique. AI will surpass us, and then we should be humble and fade into the background. And this is quite a popular idea. Also, if you ask someone on the streets, how do you see the future of artificial intelligence? You often get an answer that is related to the hypothetical computer intelligence explosion. And it's also reflected in the robot rights debate. So some thinkers say that, well, when we have these super intelligent robots, they will become a new sort of entity and we should grant them their own rights. But I think I think we should be critical about this way of thinking. And I think it's very well explained by cognitive scientists Abeba Burhane and Jelle van Dijk. And they say that what we find at the heart of the robot rights debate is a first world preoccupation with abstract conceptions that are far removed from concrete events on the ground. So we should be paying more attention to concrete events on the ground when it comes to AI. We need more AI realism, because futuristic science fiction narratives are very interesting, they are very nice can be very inspiring, but they can also obscure our view of the pitfalls and the potential of AI. So we tend to overestimate hypothetical general AI, and we underestimate the narrow AI that's already here to stay and already has a great impact on society. And according to machine learning expert Gary Marcus, the same person from the GPT-3 experiments, he says that it's also because we confuse more computing power with more intelligence. So the fact that we have more data, that computers are more interconnected and that there's more computer power doesn't mean that we also suddenly have more intelligence. And he also claims that AI is hyped up in the media a lot, which leads to overblown AI claims. And also people who work with AI say that overblown claims give their work a bad name. For example, in the field of emotion AI, which is artificial intelligence that tries to detect emotions on the basis of your facial expressions. We will see more about this later in the presentation. And another example of how AI gets hyped up and is overblown in the media is the famous cancer spotting AI by Google. Top doctors now say that, well, it was said that the AI cancer spotting outperforms human doctors. And now the human doctors say, well, these incredible claims are not backed up by scientific evidence, and it's not a very nuanced study. So I think that more AI realism is not only about being more realistic about overblown claims, it is also about paying more attention to the concrete events on the ground, so to the robots that have already arrived in the form of the supervisor and the middle manager. So nowadays, workers in, for example, Amazon warehouses are subjected to AI systems that intensively monitor their work and impose dehumanizing assessment criteria. So to satisfy the algorithm or to satisfy the monitoring AI system, Amazon employees felt they had to become a working robot themselves. So this is a quote from an article in The Guardian last year. And this was an Amazon worker who said, you're being tracked by a computer the entire time you're there. You don't get reported or written up by managers. You get written up by an algorithm. You're keenly aware there's an algorithm keeping track of you, making sure you keep going as fast as you can, because if there's too much time lapse between items, the computer will notice, will write you up, and you will get fired. So these examples of human AI collaboration that I've discussed so far, I think they demonstrate a structural trend, namely that we tend to develop robots that have to act like humans, and we expect from humans that they have to behave like a robot, like in the Amazon factory or also in click farms. And this is also reflected in the hidden labor behind artificial intelligence, because AI systems don't get smart automagically. That's why anthropologists Gray and Surrey came up with their book Ghostwork, which is all about the invisible labor that enables machines to learn. And artist Astra Taylor came up with the term folkstomation, by which she means that there's an enormous amount of human work lurking in seemingly automated systems. And this human work is offered by platforms like Amazon Mechanical Turk. So on Amazon Mechanical Turk, workers are matched to micro tasks that enable the machine to learn. For example, so what kind of microtasks am I talking about? Well, you see an example here on the slide. So people need to check, label, or transfer information from analog to digital, from audio to text, from implicit to explicit. For example, category labeling. So here you have to put objects in the right category. But unfortunately, workers have no guarantees, no labor rights, and the average payment is $2 an hour. And these workers are very invisible. We have no idea these people are even out there. So far, I've discussed examples of the AI-centered approach. An alternative approach that can be beneficial is the idea of collaborative AI, where humans are put more central. So we have to stop using AI to optimize humans for the data market or the digital technologies market, and we have to start optimizing AI for our human future. And human-machine complementarity can be helpful because there's no point in teamwork when all actors possess similar qualities. So I would say, I also wrote a paper about this, I would say that unintelligent collaborations with AI are collaborations where humans and machines are reduced to the same entities. And intelligent collaborations with AI are collaborations when the qualities of humans and machines are put together. Because there are important differences between human intelligence and artificial intelligence. So humans have, for example, common sense, phenomenological experience, willpower, intentionality, reasoning ability, empathy, etc., etc. Computers are very good at calculations, pattern recognition, processing huge amounts of data, categorizing huge amounts of data, memory capacity, efficiency, velocity, etc. As you can see, the list is incomplete. The list is open for debate. The list changes through time because obviously AI develops under the influence of what we do with it and technological developments, but also human intelligence changes through time, because when we use more and more AI tools, also our own cognitive abilities change. I want to state that we should not see this human AI complementarity approach as the holy grail. Because in theory, the idea of unifying complementary qualities is a bit like an open door. And it's also, in theory, it sounds wonderful. It's like a puzzle. You just put this and this together and then everything will be great. But in practice, collaborative AI can be very complex. So I want to first demonstrate some pitfalls, some examples of collaborative AI, I would say, gone wrong. And after that, look at the more successful examples of collaborative AI and discuss the potential. So Human AI collaboration in practice. An interesting example to look at is predictive policing. Well, first, a short explanation. What is it? Well, predictive policing is using big data and predictive algorithms to identify criminal patterns in specific geographic locations and deploy the police resources to remedy those risks. So, for example, in the Netherlands, these predictive policing tools are sometimes preferred over professionals because it's cheaper. Professionals make time-consuming decisions about individual cases based on extensive file studies and personal contact, and that's more costly. Together with Professor Remco Spithoven, I've written a peer-reviewed paper about predictive policing, and what we found was that there's no scientific evidence that it works. So there's no reducing crime in law enforcement agencies that used predictive policing. But what we did find was many unintended side effects. For example, biased data. Big data is not neutral. So the socioeconomic inequalities and cultural stereotypes that are present in our current society are reflected in the data sets. They are hardwired into AI systems and spread on a larger scale. This is problematic because law enforcement agencies take the view that arises from big data analysis as an absolute objective truth, and they search for confirmation of the predictions. So in the end, predictive policing can work like a self-fulfilling prophecy. So an algorithm predicts, for example, a criminal hotspot. Then law enforcement agencies send more police to arrest people at the hotspot. Then you input the data memorizing that the area is a criminal hotspot. And then you use that data for your next prediction, and then you repeat. So you get a negative feedback loop. Not only law enforcement agencies use these types of predictive AI systems, also local governments. The Dutch government used the infamous system risk identification, shortly SIRI, and was used to predict which citizens have a higher chance of committing fraud with taxes and welfare payments. So what the system does is it connects all kinds of data sets about tax payments, about employee history, immigration history. And then citizens are labeled suspicious, not suspicious. So very black and white approach. And very problematic because minorities and lower income groups were discriminated and wrongfully accused by the system. And that is why the District Court of The Hague in the Netherlands decided to put a ban on the system. However, alternative systems are still active in the Netherlands. Social scientist Virginia Eubanks investigated these types of systems in the United States, and she wrote this great empirical book about automating inequality, and she describes how AI technologies like big data predictions, algorithms are used to profile, police, and punish the poor. And together with Setup Media Lab, we invited Virginia to the Netherlands to advise our Dutch government. And she discussed the example of governments using algorithms to predict child abuse. And she said, algorithms confuse parenting while poor with poor parenting. So she said, well, these systems cannot deal with social complexity. And you shouldn't quantify welfare issues. You cannot put them in a mathematical model. So this is, I think, also an example of human AI collaboration gone wrong. Another interesting human-machine collaboration, which is getting more popular, is AI recruitment. So nowadays, if you apply for a job, you have the chance that you have to do a video interview where you answer a couple of questions from the company, and then you send the video to the company. And then the company makes an analysis of the video with algorithms. So algorithms analyze your language, the words that you pick, your tone of voice, but also your micro expressions. And this is interesting because emotion recognition doesn't work because our facial expressions don't correlate with emotions. So someone who has a smile on his or her face can be totally unhappy on the inside. People are actors. So you can put tons of data in the system. You can look for inclusive data, but that doesn't change the fact that our emotional statuses cannot be read plain from our face. So at Setup, we found this very interesting. So what we did is we built, we opened up the black box of algorithmic recruitment tools, and we built our own algorithmic recruitment tool. So not for companies, but to empower and prepare people for dealing with these kind of tools. So they could see how the system quantified their facial expression and quantified their language. So nowadays, AI is not only used for recruitment, but also to monitor workers. I interviewed a company that developed a special algorithm that measures employee engagement by searching work emails and chat conversations for language patterns that would reveal disapproval, insecurity, or discomfort. And they explained to me this is an example of human-centered AI because it's completely anonymous, privacy-friendly, GDPR-proof. People give approval for the algorithm, and what it does is that what they explained is that this is eventually used to make sure that people become more happy in the workplace. So a low engagement score is problematic. Then you can go to the team and you can work it out together so you can have a higher engagement on the workplace. But I think that this is not a human-centered approach because it is impossible to accurately quantify language. So they explained to me how their algorithm measures employee engagement, and they gave me the example that if you write in an email, for example, the sentence, maybe we should do something about that, then you will get a negative engagement score. If you say, let's do something about that, and you get a positive engagement score. But the problem is that you cannot quantify the intentions behind language and the social cultural context in which things are said. So there are also people who often use the word should or maybe because they are modest, or maybe because they are shy. So you can not calculate, quantify those cultural aspects, and it's not that black and white. So this is also an example of a flawed way of collaborating with AI. So the examples I discussed reveal that there are some structural problems when we collaborate with AI. We have to be aware that AI systems work best in stable environments with stable rules, but society is the opposite of stable. So humans are not like chess pieces, and life is not like a game of Go. And the pitfalls in human AI collaborations, I've made a list. I don't have enough time to discuss them all, but maybe I can do three from the list. An interesting one is, for example, ethics washing, human-centered AI. Human-centered AI can also be used as a hollow marketing frame. And it is very complex to, for example, look at Facebook. Facebook was also developed from a human-centered perspective. The goal was bringing people closer together. And now look at what happened with surveillance capitalism and where we ended up. So in the start, you can depart from a human-centered approach, but along the way, this can end up the opposite. Consistency is not the same as neutrality. We often tend to think that decisions made by AI systems are more fair and more neutral, but this is not the case because AI systems are built by humans. Humans have cultural values and these are put into the system. And the fact that an AI system judges every individual in the same manner doesn't mean that it also happens in a neutral way. So systems, AI systems, can also consistently discriminate. And very important, I think, is the past is not equal to future. AI is based on data. Data is always about what happened in the past, and the past is not always the best predictor for the future. And we saw this also in predictive policing. And I think it's important maybe to the ecological costs. When we collaborate with AI, we are often not aware of how much what the ecological costs are. So I think this was a study by the University of Massachusetts, and they performed a life cycle assessment for training large AI language models, and they found that the process of training an AI language model emits 5 times the lifetime emissions of an average American car, including manufacturing the car itself. And I know that there are already people working on how we can do it better. So now that I've discussed the pitfalls, we can finally have a look at the potential of human AI collaborations and see more positive examples. So what can we do with it? Well, together with Media Lab Setup and artist Casper de Jong, who is on the picture, we investigated this question and we developed a Pottery Bot. And the Pottery Bot envisions new complementary relationships in which humans and machines work together. So you have to collaborate with the robot and you can let your best qualities intertwine and blossom. So you can finally forget about the robots and the AIs that will beat or replace us. And you can celebrate the awkward dance between man and machine. Another example, what we can do with AI is debating. So IBM developed this great debate robot. But unfortunately, in the media, it was presented like a contest where the debate machine has to beat the human or the human has to beat the debate machine. But what's way more interesting is to use it to learn new viewpoints about a particular topic, to sharpen our own thinking process. So I think debater can be, especially in a time of information bubbles, can be a good example of how we can collaborate with AI in a more constructive manner. Another example are augmented reality glasses and smart beamers in the workplace that add an extra layer to reality. And this allows technicians and doctors to better see where to drill, screw, cut, or operate. And as a result, the employees experience less physical and mental strain. And my final example is pixel farming, where artificial intelligence is used for biodiverse farming, designed to control weeds without the use of pesticides. An example is an algorithm that calculates a sustainable cultivation plan for crops based on natural crop protection. So this could also be a great collaboration between nature and humans and artificial intelligence. So in order to come to a conclusion, in order to collaborate with AI in a constructive manner, we have to ask the right questions. So I think that the right questions are, for what purpose is this AI system developed? Whose interest does it serve? What can and cannot be properly quantified? Which human values cannot be captured in data? Which moral assumptions are indirectly incorporated into the AI system? Who can understand and control this system? So this is about transparency and opening up the black box. And finally, what are the differences between human intelligence and artificial intelligence, and how can they complement each other? And we should avoid tech solutionism. So technological progress is not the same as societal progress. So the idea that given the right code, algorithms, robots, and digital technologies can solve all mankind's problems is, I think, naive. Because technological progress does not solve the fundamental shortcomings of the social, economic, and political systems in which we live, and it doesn't solve the moral shortcomings of humans. So there's no technological fix for inequality, especially not when humans are permanently considered as the temporary helpers of artificial intelligence. So this is of course open for debate, and I hope it's something to think about. So I think we can go to the questions right now. You can ask them immediately, or you can also email me. Thank you for your attention.
Thank you, Siren. It's an excellent presentation. I was very thrilled to hear so much about artificial intelligence, although, you know, still I'm reading and watching about this topic quite a bit. But that was an excellent comprehensive overview where I did hear new things. So
okay, that's good to hear.
I really loved it. And I have quite a bit of questions. So I'll start with the first question. And if in between someone else we've come with any questions, I will just give them a ground, but I will start with the first question. So I have quite a difficult ones, but I will start with a simple one.
Okay.
For a starter. So at the beginning of the presentation, you have mentioned general AI. And you said that some people claim that we already have it or we are about to have it.
Yeah.
And what are the examples of applications? So what do they rely on when they say this?
Well, when GPT-3 entered the public debate, there were some people who said that GPT-3 already was an example of general AI. Mm-hmm. And it was also immediately an object of debate that others say, well, this is not general intelligence. So that's an example of where there is a debate about whether it is the beginning of general artificial intelligence or not.
Okay, thank you. So anyone else having a question? Let's bring it on. Otherwise, I will keep asking questions. Well, okay. Until everyone is thinking. So I have this very big and very loaded question actually.
Okay.
So I was reflecting on what you were saying, and I remembered two important periods in 19th century. Mm-hmm. So first was in the beginning, the movement of the Luddites.
Yes, yeah.
Machines, right?
Yeah.
So that's one part of the question. Now, how to address that kind of thing and the complementarity between people and the machine, because indeed, you know, to use AI, you know, in your daily work, you need to have a certain skill set, right? So the people who have the old ways of working, they may suffer and they may have a problem, you know, to reskill themselves, right? And it could depend on multiple things. So one side of the question, how to onboard people? What's the prospective approach, which is ethical and nice to know, just to ease the prospective tensions regarding that?
Yeah, so how to avoid that people will turn against AI in the workplace, how to make sure that they are.
Yeah, that's on one side when they are when they have to use the tools, you know, to keep having income. The other question, the other side will be about suffering from AI in a workplace. But the first question is on how suffering in labor market because of AI.
suffering in the labor market.
Yeah, so when you don't have you cannot find a job, or you have
Yeah.
a bad job because you don't have technical skills to use applications based on AI.
Well, I think it's very problematic to think that the jobs of the future will only be technical jobs. I think that that's also what I demonstrated in my presentation, is that the human eye is very important to contextualize the decisions made by the computer. And I think there are multiple ways of collaborating with technology, and we don't have to become all technicians in order to collaborate with AI.
Mhm.
And the second question was more about how we do it in the workplace, right?
Yeah, so I just
Or,
want
yeah,
you to remember now, in the Victorian industrial period,
yeah, the
we have this,
Ludics.
yeah,
Yeah,
bit
well,
so a bit later on, when fast forward to the second half of 19th century, we had factories really, becoming sweatshops, and
yeah,
really pushing performance from their employees. And for example, now these are the examples when you said when your work is being monitored by AI and
yeah,
being
I think that's, yeah. Well, that's an example of what you shouldn't do. But I think that a good way is, there was this, for example, the augmented reality in the workplace was something that the workers themselves found very comfortable. And it was also, there was a study by TNO here in Holland, and it was about how the skill set of the workers changed when they worked with the glasses. So when you put the glasses off, do you still have the skill set to operate? So that's also an important question. How does this intervenes in my own skill set? That's something that you can investigate, and you can take that into account. So making sure that also the people have enough space to develop their own skill set, so they are not do not become like zombies, where the machine has to do all the work and you just have to, like a slave, have to follow. I think there you can do many things to prevent that. Like the study, but with how the skill set changes.
Yeah, one of the underlying assumptions I was having in my question is that we often hear, those perceived threats, right, by the people.
Mm-hmm.
So we all, I believe most of us in this webinar, we are fully aware, of the benefits AI is about to give us, especially if it's provided in ethical manner and it works just fine, and it
Mm-hmm.
really enriches our lives. But still, some people, may be very suspicious, right? They may be afraid of their future of their jobs, or they may be afraid of being monitored too much. Even now, in the
But yeah.
that was a discussion: should people be monitored, and should they be, let's say, labeled as a prospective people who have COVID-19, right? Although that would bring value and benefit for the whole society, but on individual level, it may bring some restraints to which some people may not be comfortable with, right?
Yeah, and I can imagine why people can be uncomfortable with that. And I often get the question also how can we eliminate that people are scared of AI? But I think that's the wrong question. You have to you don't need to eliminate this being afraid of AI. You have to use it and work with it. I think that it's wrong to only have the goal that you should take away the fear for AI, because there are very grounded reasons why we should be afraid of it, because what it can also have very negative consequences, especially for like the underclass people who now do jobs that pays $2 an hour to enable our AI to learn. I think that's not a good example. And I think they are completely right to say that that's not what we should want. So, yeah, but I think that we are afraid of AI from from unrealistic, like the science fiction perspectives, I think that's not very realistic. I think that's not what we should be afraid of. It's more also the political, social, economic systems in which AI is embedded that are problematic. I think that's my perspective.
Well, indeed, because say in Europe or in Western world, it's we have a discussion on that. We have various movements, as for example NGI, which in a way contributes right to ethical and well-structured approach. But meanwhile, we have examples, as you said, like in societal and political structures, as in China, when we have people being monitored and labeled, and in a way they have a set of rules to which we have to oblige. And if not, they may suffer, some what's the right word? Some not good things for themselves, for the social ranking, as we call it.
Yeah. The social credit systems. You mean the social credit system? Yeah. But I think we in here in the Western world, we also have a social credit system. It's called social media. Yeah.
Yeah, but it's bottom up in a way, and the Chinese approach is top down.
Yeah. But we also rank each other all the time. So yeah.
Well, but here's a social media. It brings us to, as social anthropologists would say, the prestige thing, right? So now, how much perceived prestige you have, and in Chinese case, now that means what job you will get or what debt you
exactly, yeah.
Things. So that could be, so that people are being put into certain social framework they have to go for. So that's basically this social constructing in a way.
Yeah, absolutely.
So just a bottom line here, I guess, as we often say, European Union works as a very strong global body of regulations, and the research we are doing, the research you are doing, and those inputs to this general narrative we have in our society, European society, very important, to really crystallize cornerstones, the ideas, the values, all the aspects we have to navigate according to build this inclusive and effective system which people accepts and enjoys using.
Yeah, totally agree. Yeah.
And please, anyone else, give some questions here, because I was very much one-sided to a certain topic regarding AI. So more diverse questions would be very welcome. If not, I can have one very last question.
Shoot.
So yeah, although you mentioned about the drawbacks of predictive policing.
Yeah.
And we all know the drawbacks, that's how it's being, how it works. I just wanted to share one story and hear your reflection on that. So in the US, this tool is very popular. So many municipalities use that. And we don't use the same tool, they all develop their own tools. So if you develop your own tool, and if you're looking for certain variables you're looking for, you can make it very much biased, and we know that US has all kinds of places with very different biases and approaches to social structure and things. So just, I guess the question is, those applications, should they be, let's say, centralized? Or should they be, as predictive policing, if we would pursue this avenue, as if somebody would at some point figure out that how to make it work, more or less?
Yeah, but I think it's not I don't really have an answer to how if you should it centralized or decentralized. I think it's way more important to look at what it does in our way of thinking and categorizing. So you can organize it in a better or in a good or in a bad way, but that doesn't change the fact that it's still data and it still categorizes, and the self-fulfilling prophecy. I think you cannot solve that, also not when you organize it centralized or decentralized. Of course, I have to admit there are steps we can take to make it less worse. But in the end, these like the slide I showed that society is not a board of Go or chess play. I think we should not, you cannot reduce security, you cannot put security into these mathematical models. You can work with it, but it has to be a tool you cooperate with. But in practice, that doesn't happen because people take what comes from the data as an absolute truth. So I think we first have to be able to nuance the insights that arise from big data. And when we are educated in this, so when security professionals are educated in this, then they can work with these tools. And then we can also have a discussion about how it should be organized, centralized, decentralized. And you are right, or in the United States, there are like Clearview AI, there are it's the famous company that the security professionals, they work together with these companies. That's not a positive outlook, and you can also do something about that, I think. Yeah.
I think it's very much this thing as we have in Western science philosophy, that whatever you are investigating, you should be aware of the biases. You know, there's human biases, machine biases, and
Yeah.
we have to be very conscious while using those tools.
Yeah.
Okay, so I guess it's very last chance to give a question. If not, we'll wrap up this fantastic webinar. Well, you're lost, man, because to hear some very good insights. So thank you, Siri. Thank you once again.
You're welcome.
I did really enjoy the webinar.
Yes, I did.
Looking forward to hear some more news from your research work. So what's in the field?
Yeah, sounds good. Thank you for having me.
It's our pleasure. Thank you once again.
Okay.
Have a nice day, everyone. See you later.
Bye-bye.